Well, good morning. I hope you got some sleep. Probably not. I heard a lot of no's. Let me try to. Okay. Is this you or me? I don't know. Anyway, so welcome to our topic today, embedding V8 in the real world, or more specifically in NativeScript. My name is Stanimira Vlaeva, and I'm here today with my colleague Vladimir Mutafov from the NativeScript core team. And we'll be describing how we embed the JavaScript engine V8 inside the NativeScript Android runtime. The story we are going to tell today has 4 parts, and we will actually start with a short introduction first. So what is this NativeScript thing? Just to make sure that everyone is on the same page, we will talk a little bit about NativeScript. How many of you have heard about NativeScript or ever used it? Okay, that is a good number, decent number. For everyone who couldn't see the whole, everyone raised their hands, so we're good. Okay, so NativeScript is a framework for building native mobile applications for Android and iOS using some technologies that are usually used in the web world or even in the server-side world with Node.js, and I mean JavaScript, of course. And of course, you can also use 2 of the more famous front-end frameworks nowadays, Angular and Vue.js. So basically, it's a way to run JavaScript in the mobile world. We'll take a look at the architecture overview of the framework. At the bottom, we have, of course, the operating systems, Android and iOS. On top of that, we have the NativeScript Android runtime and the NativeScript iOS runtime, which allow us to have native API access to the underlying APIs. But of course, if you ever had to build mobile applications for Android or iOS, you may have noticed that the way to build user interface or to do anything at all is slightly different. That's why we have a common abstraction layer that is written in JavaScript, and you can access it through JavaScript while you're building your NativeScript application. And it provides you with abstraction for building layouting, for building user interface widgets, for styling your components using a common web paradigm, CSS. And basically, it's a way to abstract things so that you use the same code base for Android and for iOS. We have a very tiny, lightweight application framework that provides you with standard things like data bindings, navigation, and some other very, very limited number of features. And if you need something a bit more sophisticated, of course, you can use Angular or Vue.js. But today we're going to focus on the bottommost parts, the native API access layer. And more specifically, we'll talk about Android. And why is that? Because for Android, we're using V8, and for iOS, we're using another JavaScript engine, JavaScript core. You can think of the 2 runtimes as being pretty similar, but still at their core, they're using 2 different JavaScript engines, and that's why they have some slight differences. And as you may have noticed from the name, NativeScript, one of the most important features for the framework is the 100% API access. So I'm going to invite my colleague, Vladimir, and he will describe how NativeScript achieves that.
Hello. So as Stanimira mentioned, one of the main benefits of using NativeScript is that it provides 100% native API access. What this means is that developers should not spend any time writing custom JavaScript wrappers or adapters to use native functionality. They can use the native APIs as they are. To achieve this behavior, many things happen under the hood of NativeScript. And let's take a look at what the application package of a NativeScript app looks like. At its core, every NativeScript application is just a regular Android application. However, there is some NativeScript magic inside of it. And let's look into that. Of course, we have the developer's JavaScript code, where most of the business logic of the application resides. We have the NativeScript runtime, both the C++ and the Java parts of the NativeScript runtime. And this could be thought of as the glue between V8 and Android's runtime. Yeah, I mentioned V8, and let's talk about who executes the JavaScript. Inside every NativeScript application, we ship V8, which is the same JavaScript engine used in Node.js, Google Chrome, and even Microsoft Edge nowadays. There are many reasons why V8 has been chosen as the engine for running JavaScript, and probably the most important points are that it provides exceptional execution speed of JavaScript, and it has a pretty nice embedders API. We're not going to talk about the internals of V8, how it works, how the garbage collector or the just-in-time compiler work, but probably those blog posts and videos would shed some light on how modern JavaScript engines work internally. We talked about that we can use native APIs, but let's take a look at an example. We see here that we're trying to create an instance of a media recorder class, but what are actually those Android media recorder words? Who declared them? What are those variables? We don't see them anywhere around the recorder variable. How can we use them? To understand this, we have to look at what happens at build time of every NativeScript application. So every time the NativeScript developer runs a build of its app, a special tool is triggered. It's called the Metadata Generator. Its goal is to parse every native library, for example, the Android SDK or any other native library which the developer imported, and from them to collect information about every package, class, interface, all the fields, all the methods, everything from the native side, and store that in a compact runtime binary. And this binary would later be used when the application is run. So we can understand that these special words are some kind of metadata about the native world. But how do they work? Let's take a look at what happens at application launch. So when the application runs, we initialize V8. We load the JavaScript code, we compile it, and it's almost ready to be executed. Then we load the metadata and attach some callbacks. But what are those callbacks, you may ask? And I mentioned that V8 has a pretty nice embedders API, and this API allows us to create programmatically JavaScript objects and attach them to V8, and have some callbacks attached to their properties. So when somebody accesses a property of these special objects, we can receive a callback and do some logic. So every time the application launches, we load the metadata, and for every root package name, this is, for example, in this case, Android, or Java, JavaX, COM, whatever root package name, we set a global object to the running V8 instance. And this special object has some properties. These properties have some callbacks. And for example, when you access the media property of the Android package, a package getter callback is triggered. Then the invocation is delegated to our NativeScript runtime. We find in the metadata that media is actually a sub-package of Android. And we return, again, a special object which has some properties and some callbacks attached to them. Then, in the example, we access the media recorder property. Again, the package getter callback is triggered, but this time we find that the media recorder is actually a class. It's not a package. So we return a special constructor function. What is interesting about it is that it has a constructor callback. And when somebody accesses this constructor function, the execution is delegated to NativeScript. It then instantiates the native object in the Android world. But how do we do that? Well, we use JNI. JNI is a foreign function interface framework used in both the JVMs and the Android runtime. What it does is to provide access to C++ from Java and vice versa, access Java from C++. And in NativeScript, it could be thought of as the bridge between V8 C++ and Art or Dalvik Java code. After we instantiated the native object, we create a special JavaScript proxy object. This is similar to the special proxy objects we mentioned a couple of minutes ago, and again, it is quite similar to the native media recorder class. The proxy object has the same properties, the same fields, the same methods, but it has callbacks attached to them. We return that to V8, and for example, if we access some random field, a field getter callback is triggered. And the NativeScript runtime queries the original Java object, finds some random field property, but what should it return? We have its value, we have its type, but there's a slight complication. V8's types and Android's types are quite different. So it would be really convenient to have some marshalling service to convert the data between the two VMs. And for example, for primitive types like strings, integers, doubles, they're converted to their analog in the other world. However, native Java objects are, as I mentioned, proxied to special JavaScript objects. Accessing a native method through JavaScript is quite similar. This time, a method callback is triggered. We call the method on the Java object, and the result is marshalized and returned back to JavaScript. Probably all those callbacks have a bit confused you by now, so let's have a brief overview over the example. So when we try to instantiate the media recorder class, the constructor callback is triggered, and the execution is delegated to the NativeScript runtime. It then requests an instance of the class from Android, and after it returns an instance, we return a proxy object. When we access a native method, the method callback is triggered, the NativeScript runtime calls the method on the native object, and if the method is not void, the return data is marshaled and put back into V8. So we can see how we can use native APIs, but probably some of you are wondering what happens with the lifecycle of the objects. We know that both JavaScript and Java have garbage collectors. We know that developers should not explicitly delete the memory used by an object, and somebody else do that for us. And yeah, this is the garbage collector. Its main goal is to find objects which are not in use in the application and retrieve their memory. We're not going to speak about its other roles, like keeping the memory not fragmented or saving us from memory violations. But the fact that both V8 and Android's runtime have garbage collectors creates a slight problem for NativeScript. And we have to ensure that no object is removed from the memory while the other virtual machine may be using it. To achieve this, we use some tricks. And one of those are that we attached for every instantiated native class a special finalizer callback. These V8 callbacks are triggered every time V8's garbage collector determines that an object is dead. So we catch these callbacks and check the actual live state of the object on its native site in Android. Also, every time we create an instance of a class, we store a strong reference to it in an internal collection of ours. And we're going to discuss strong and weak references a bit later. Let's take a look at what happens when V8 initiates a garbage collection. So it determines that an object is dead for V8. It calls its finalizer, and the execution is delegated to NativeScript. So we check if we have a reference for it, Initially, we see that we have a strong reference. So we make it weak and tell V8 to keep the object alive. Suppose we have a second garbage collection, again for the same object. The finalizer is triggered. We check if there are any references, and this time we see the reference is a weak one. And this case by itself has two micro cases. We can either have a value inside the weak reference, or we cannot have a value. And this depends on the Android's garbage collector. So probably this is the time where I should describe what a strong reference is and what is a weak reference. Actually, in Java, when you instantiate a class, it has a strong reference. And when the Android's garbage collector sees strong references, it determines that the object is still in use. However, we can create weak references too. And the difference between those reference types is that when the Android's garbage collector sees a weak reference, it may collect the object. No one is stopping it. So you can see that deleting an object created from JavaScript is quite dependent on V8 and Android's garbage collector. And this is probably one of the main challenges of the NativeScript runtime. You can see that Java objects need several garbage collection cycles to be removed from the memory. This is actually not a problem because objects tend to be small. They do not use so much memory that they create a problem. But if we are dealing with native arrays from JavaScript or native images from JavaScript, we may run out of memory. So to fix this, there are a couple of ways for the developers to overcome these issues. One of the solutions is to trigger several garbage collections. However, for me personally, this is not so good fix of the issue. Because triggering garbage collections is a really costly operation. The garbage collectors would need to iterate through most of the memory, check the life state of objects, and yeah, this is not a cheap operation. Perhaps there's a better way, and it is to use the release native counterpart function. What this function does is that when you provided a native object as an argument, it would remove any references stored for this native object inside the NativeScript runtime. And this enables the Android and V8's garbage collector to retrieve the memory used by the object. So we talked about object's lifecycle, and I'm going to invite my colleague Stanimira to talk about the multithreading part of NativeScript.
Thank you. All right, for the last two sections, where we will actually discuss two problems that we solve in NativeScript using certain V8 APIs. And the first one is multithreading and how we try to achieve it from the JavaScript side. So the JavaScript code in NativeScript is actually executed on a single thread, which actually happens to be the main user interface thread. It just can cause certain problems. But let's start from a little bit afar. Our modern devices operate at a frame rate of 60 frames per second, which means that every second they have to draw 60 new images on the screen. If we do some simple calculations, we notice that we have up to 16 millisecond budget for drawing a single image on the screen. And this essentially means that whatever computations we're trying to do at this point in the JavaScript side, we should finish them and be able to delegate the task of drawing something on the screen to the Android operating system. And if we fail to meet that budget, and if we exceed that budget actually, the frame rate will drop. We will skip a frame, and essentially the frame rate drops. The percentage of dropped frames is what we call jank. And many of you have experienced that in different applications. Let's see this short video, And I'm going to set the speed to the slowest possible one so that we can clearly see the difference. We have an animation running at 120 and 60 frames per second, which is here essentially the same because the device is running at 60 frames per second refresh rate. And the animation is pretty smooth. When we have an animation running at 30 frames per second, you can notice the slight lag that we see. And at 15 frames per second, or 75% of jank, you see that the animation is running in a not very nice looking way. And because we're building mobile applications in NativeScript, and I mean native mobile applications, we don't really want that experience for our developers. But first, when would you have no problem while building NativeScript application? When would you not experience any jank? If you're building user interface, as I mentioned earlier, NativeScript actually builds and creates native Android and iOS widgets, which are highly optimized to be built and drawn on the screen. And for example, if you're building a list view, this is a native Android list view, which has nice things like recycling, and you won't experience any problems while scrolling the list view. If you're building animations, you have several ways to build animations in NativeScript using JavaScript, using CSS animations, or even using Angular animations. But in the end, these animations are using the native APIs for Android and iOS again, which are, again, highly optimized and are built in a way that they're performant for these devices. If you're doing a network request, under the hood, NativeScript actually uses an API which creates a background thread in the Java world, which means that we're not going to block the main thread with HTTP or network request. And what is the case when you have jank and you may exceed the budget for drawing something on the screen? Well, if you're executing CPU-intensive JavaScript code, you may experience certain problems. And it's important to notice that the same thing will happen in a native Android application if you have CPU-intensive Java code that is being executed. So how do we solve that problem? With worker threads, which are essentially background threads in the JavaScript world. We're exposing this API to the NativeScript developers so that they can create a worker thread and offload some CPU-intensive operation. And the API is actually based on the Web Workers API. It's quite similar. The implementation is also maybe a bit similar, although quite different. And it's important to notice that we don't have JavaScript memory sharing. So we have a way to communicate between the worker threads and the main thread and vice versa, but we can't share memory. We have to pass in certain results, and these results are actually serialized. So it's not the best idea to deal with passing huge objects or arrays or anything like that from the worker threads back to the main thread. Okay, I'm going to ask you a question. How do you think we implemented worker threads, or what are essentially the worker threads? And first I'm going to start with a bit of V8 theory, and then you have to guess the right answer. Okay, the first option is isolate. And isolate is basically V8's way to isolate some memory for JavaScript code that is being executed. Every V8 instance by default has a single isolate. And isolates can run in parallel because the memory is, again, isolated. One isolate cannot touch the memory of another isolate and corrupt it. That's why we can run them in parallel. Context is a similar, not really similar, but connected term. And the difference is that one isolate can have multiple contexts. And also, we don't have memory isolation for contexts, so that we can touch the memory of one context from another context. And that's why it's important that when we are executing some JavaScript code in an isolate, to explicitly specify the context. And again, context can't run in parallel because there is no memory isolation. So how do you think what do you think is a worker thread in NativeScript? Isolate? Okay, what about context? Isolate again? Okay, more people now. Cool, it is an isolate. again, we can run them in parallel, and there is memory isolation. And that's why we need to pass the results from the worker threads back to the main threads and serialize them. And again, it's not a great idea to create many worker threads because this is spawning a new isolate which has a certain overhead. All right, and the last topic that we're going to see today, we will talk a little bit about performance. And more specifically, everyone's favorite topic, startup performance. What takes time when we start a NativeScript application? When one very big chunk is the file system requests. Yes, we don't need to do any kind of network request because all the files, all the resources are probably on the device and we have them already, but we need to do quite a lot of file system requests. And actually file system requests on some of these devices that our Android and iOS operating systems work on are not the fastest thing ever. And if we have many, many file system requests, for example, if we decided to ship hundreds of Node modules and we didn't really pack them, and we start launching a lot of files at startup time, we may have quite a lot of file system requests, which can take quite a lot of time. After we load the JavaScript code, we should actually parse and compile it. This is, again, V8's work, and we don't really have to do anything there. We just delegate this work, and V8 executes the JavaScript code that we loaded. And these few steps in a very unoptimized NativeScript application from 2 years ago actually used to take quite a lot of time, 2 seconds. I mean, come on. We're talking about NativeScript as a framework that allows you direct API access and doesn't have any overhead because of the really nice bridge and how it's implemented, but then you started your application and just to load the JavaScript code, the initial JavaScript code, you need 2 seconds, which is obviously an overhead. That's why we did quite a lot of work in the NativeScript team for the past 2 years to minimize that and provide a very nice experience for getting started performance out of the box. All right, how did we achieve that? The first step, we provide support for bundling your application by default. Of course, if you have 3 files to load from the file system instead of 10,000 files, you have fewer file system requests, which apparently leads to a faster launch time. And in NativeScript, the way to do that is by using Webpack, and we actually have a pre-configured Webpack configuration, so you don't actually have to go through the hell of writing your own Webpack config. And you can start using Webpack out of the box. What about parsing and compiling JavaScript? How much does it take? What actually happens there? Well, we said that V8 is a very nice modern JavaScript engine, very, very performant and really cool to embed. And actually, there is a certain overhead because when we boot up V8 and we tell it to execute some JavaScript code, we have quite a lot of steps. I'm not going to go through each of these steps. There's a very nice blog post by Adios Mani on JavaScript startup performance, and it briefly touches on what happens under the hood. But my point is that we don't simply start interpreting the code one by one. There are a lot of steps, and there is a certain overhead while executing the JavaScript code. But we can't just skip this step, right? We need to execute the JavaScript code. And at this point, we're executing the code when we boot up the application. And there is a very nice feature in V8 that actually allows us to execute the JavaScript code at build time. And later on, skip this step while we are starting the application. It is called custom heap startup snapshots or something like that. It's basically a snapshot of the heap, of the memory. And let's see how it works. So when you decide to build your NativeScript application with the snapshot flag enabled, the project files are bundled with Webpack. We have a few output files, and actually the NativeScript build picks up one of these files, which happens to be containing all the external packages, and runs that file through V8's snapshot generator tool. That snapshot generator tool creates a new instance of V8 with a new isolate and executes the vendor.js file in a new context. Then it takes a snapshot of the heap, the memory heap at the current time, and saves that to a binary file on the file system. The NativeScript build takes these files, these binary files. They're different because we will be running the application on different devices who have different architecture. So the NativeScript build takes these files and saves them inside the actual application package. Later on, when you start the application on a mobile phone, the NativeScript runtime loads the snapshot binary. It creates a new isolate, and this isolate actually is set up in a way that the context is the same from the context that was saved in the snapshot binary. This means that we can skip executing the vendor.js file, the file that contains all the Node modules. The limitations, of course, are that we are executing this JavaScript code in some bare context, so we don't really have access to the native Android APIs at this point because we are executing the code at build time on our developer machines. And how can we work with that? Well, here's a very simple problem. If we try to run this code through the snapshot generator, we will get an error because we're trying to access Android OS build version, and Android is not available at this point. So one very, very simple way to solve this problem is to execute this code and wrap it in a getter, and later on lose this getter lazily. Everyone okay with that? Okay, if you're not, just be lazy, follow this advice. And that was actually everything. Thank you for the attention, and we are waiting for your questions. Thank you.
Give us a couple of seconds to just put this on the stage.
Yeah. Thank you.
So we have a couple of questions from the ground and from myself. Yeah, and I think the first and really obvious question, we have React Native. So what do you think? Yeah, I believe anyone ask you these questions, but what is the main difference between NativeScript and React Native?
Okay, well, one very obvious difference is that React Native works very well with React. So if your framework of choice in the web is React and you want to reuse some code or your skills, maybe the obvious choice is React Native if you're using React. In NativeScript, we're focusing on the plain JavaScript part and also Angular and Vue.js. So this is one very main obvious difference, and for internal differences, they're actually quite similar.
Yeah, actually nowadays React Native probably a couple of months ago had a refactoring, and their runtime is nowadays quite similar to NativeScript's runtime, so they provide native API access as well. But at the beginning, this wasn't the case for them. You had to write some custom wrappers, adapters, you name it. But yeah, nowadays the runtimes are pretty similar, and the main difference is that, like Stanimira said, we support Angular, Vue, JS, TypeScript, and they support mainly React.
But we know that React Native sometimes have the limitations with because of the serialization and type conversion between the worlds. And for example, if you're trying to build some smooth animation or something like that, because the overhead of type conversion between worlds, it maybe not looks really nice. So what is the NativeScript solution for this problem, or there is no such problem?
Well, I believe it was the way, actually, how it's built. One thing we do is we run the JavaScript on a single thread, the same main UI thread, and React Native used to run that in separate threads. So that's one thing that was causing some overhead, but I'm not really sure how the new bridge for React Native works, so I can't really comment on that.
Yeah, I can't comment for sure about all the parts of the new React Native bridge, but yeah, its old one suffered from these kind of problems regarding animations. But in NativeScript, there is not so much drama about animations. And actually, the slowest part of the NativeScript runtime is perhaps the JNI, because everything we do is actually cached. And yeah, JNI is probably the bottleneck, but actually, Android animations, if you are writing Java or Kotlin, you go through this JNI bridge. So in NativeScript, the performance is quite similar.
Okay, the next question is about multithreading. And for example, if I have some heavy computation, some business logic, and I want to be that really performant, can I write some chunks of code in native platform, for example, in Kotlin or maybe Swift or something like that, and connect them to NativeScript?
Yeah.
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 So maybe a couple of things about that. Is it hard, or how can I do that?
It is relatively easy to write. You can definitely write in Java or Objective-C. You can also have some library from the Java world or the Objective-C world, and you can embed that in the NativeScript application. I'm not sure about, we don't really support Kotlin, but we're working on that.
Yeah, we're working on that. Actually, most of the features of Kotlin are supported because, as you probably know, it is compiled to Java bytecode, and we, in the metadata generator 2 I mentioned, we parse bytecode. We don't parse Java or Kotlin, we parse Java bytecode. So most of the features of Kotlin could be used, but there are some cases, for example, like companion objects, which need some work from us to be able to use them from JavaScript. But if you want to use some native library, it is as simple as including in a Gradle script of ours the wanted library. And at runtime, you can access everything from it. No other things to do.
And next question about overhead. What's the, how big is runtime, and for example, how many bytes added to my APK file or something like that, because you have so Embedded V8, so what is the overhead?
Yeah. Do you know numbers?
Maybe not numbers, but is it big?
Well, I'm not sure about the exact number, but the APK is not so much bigger than a regular Android application, because V8 is a virtual machine, yeah, but it's not so big. It's not like the JVM 200 megabytes, for example. It is really small, and the basic NativeScript application is, I think, something about 15 megabytes, the APK, which nowadays, I think it's not a problem for modern phones.
Okay. The next question is about, right now, mobile world is really crowded and really competitive market. We have PWAs, we have mobile versions of some applications, I don't know, Ionic, React Native, all of that. So what do you think, what the main pros and maybe cons of NativeScript in this world?
Yeah. Well, we may have different opinions on that. So for me, yeah, the native API access is obviously a very good advantage compared to the other frameworks out there. And of course, the support of Angular and Vue.js. They're quite nicely integrated, and you can reuse a big part of your project and actually have a single code base for web and mobile, where you can reuse all the business logic and just write different user interface for each platform. So for me, this is the biggest benefit.
Yeah, for me it's quite the same. Personally, the best thing I like in NativeScript is probably the Vue.js support, because I like Vue. And yeah, the native API access is, again, one of the best things of NativeScript. Because, for example, Bionic, it's not so easy to use native APIs or functionality.
Yeah, and probably the best part about the native API access is that, yeah, you won't be writing Java code in your NativeScript application every day, but you can take some existing Java library that solves a problem that you have, and you can just reuse that in your NativeScript application. You can embed it and start using it because of this API access. You don't have to write additional wrappers for it.
You said that, so for example, if I want to create UI for the Android and iOS, can I do something in code like switch if platform is Android? I draw some widget like Android-like widgets.
Yeah, you have full control on that.
So yeah, okay. And I believe the last question is: so, what do you think? Yeah, right now we have so many options on the market, and what is the best use case for the NativeScript? Is it a small company who want just some small application for the business, or maybe if you have a big team of front-enders who don't know Android or something like that? So what's the best business case or something like that?
Well, we have some enterprise clients and we have startups that use NativeScripts, and yeah, these companies have really different teams. But I think the most useful way to use NativeScript is if you have JavaScript developers who need to use their skills to write Android or iOS applications or both. And especially if they are writing in Angular or Vue.js, they might find NativeScript quite convenient to use in order to build a mobile application without with an actually really small learning curve.
So do you believe that in the nearest future there would be no other languages, only JavaScript? You can write everything in JavaScript?
No. Definitely not.
Yeah. Okay, thank you very much, and yeah, thank you.
Thank you.